Hello friends, I am Balaji Rao. Welcome to BR Max class. This is 6th class on Principle of Mathematical Induction. In this class, we will do little different problems compared to earlier problems. You observe here, we need to prove this statement by using Principle of Mathematical Induction. See, which statement I am trying to prove, I considered that statement as P of n. Now, to prove this statement by using Principle of Mathematical Induction, we need to prove two things. First one, P of 1 is true. Second one, by assuming P of k is true, you need to prove P of k plus 1 is true. First, I'll prove P of 1 is true. You see here, to prove P of 1 is true, first I considered n equal to 1. Here, I am calculating left hand side part of this statement. I just considered this nth term. In place of n, I written 1. So, I got LHS is 1. Now, you consider right hand side part. What is right hand side part? 1 by 8 into 2n plus 1 whole square. In this statement, wherever n is there you write 1. Then what you will get? 1 by 8 into 2 into 1, 2. 2 plus 1 whole square. 2 plus 1 is 3. 3 square is 9. 9 by 8. 9 divided by 8 is 1.125. Okay. Generally, till now whatever the problems we did, we checked LHS equal to RHS or not. But here, you see less than symbol is there. So we will check that LHS is less than RHS or not. Here, left hand side part I got 1. Right hand side part I got 1.125. You check that 1 is less than 1.125 or not. Is one value less than 1.125? Yes, this is true. 1 is smaller than 1.125. So, what I can say here, LHS is less than RHS. That means this statement is true for n equal to 1. From this, what we can say? We can say that P of 1 is true. So, we proved first part of this question. Now, second part. What is second part? By assuming P of k is true, we need to prove P of k plus 1 is true. Correct? So, first, I'll assume P of k is true and I'll write what is P of k. You observe here, I assumed P of k is true and I written P of k. How you will get P of k? In the statement P of n, wherever n is there you write k. Then you will get P of k. In almost all the problems after this step, we will add a term on both sides. What term we will add? How to get that term? In this P of k, in the kth term, you observe here, this is the kth term. In this term, wherever k is there you write k plus 1. Adding k plus 1 on both sides. Here one point, k is a natural number. So, k plus 1 is also natural number. For an inequality, if we add a natural number on both sides, whatever you will get, that is also true. So, for this inequality, I'll add k plus 1 on both sides. You observe here, for this inequality, I added k plus 1 on both sides. What is our intention? We are trying to prove P of k plus 1 is true. It is important to keep in your mind what is P of k plus 1. So, first I'll write here what is P of k plus 1. How you will get P of k plus 1? In this P of k, in this statement, wherever k is there you write k plus 1. Then you will get P of k plus 1. It is important to keep in your mind what is P of k plus 1. That's why I am writing P of k plus 1 here. You see this, I written P of k plus 1. In this statement, wherever k is there you write k plus 1. You see here, 2 into k plus 1. That is 2k plus 2 plus 1. That is 2k plus 3 whole square. It can be understood easily. In this statement, in place of k, you write k plus 1. Then you will get P of k plus 1. Now, come to the main point. As we assumed P of k is true, we are trying to prove P of k plus 1 is true. So, as you assumed this statement is true, after adding a term on both sides to this inequality, whatever you get, that is also true. This is true. You can observe here, this is left hand side part of p of k plus 1. This is left hand side part of p of k plus 1. Only thing what I am trying here, this part is RHS of p of k plus 1. So what I will do, I will start simplifying this right hand side part. Okay. What is LCM here? LCM is 8. What you will get in the numerator? In the numerator you will get like this. 2 plus 1 whole square plus 8 into k plus 1. Now you expand this 2k plus 1 whole square. 4k square plus 1 plus 4k plus 8 into k plus 1. Multiply with 8. 8k plus 8 divided by 8. And I'll simplify this little bit further. 4k square plus 1 plus 8. 1 plus 8 is 9 plus 4k plus 8k, that is 12k divided by 8. What I am trying? I am trying to get this statement as like this. You observe the numerator part. See, this I can write like this. First I'll write 1 by 8. Now what is remaining? 4k square plus 9 plus 12k. You can observe this. This is nothing but 2k plus 3 whole square. It can be understood easily. You expand this, a plus b whole square, 2k whole square, that is 4 square, plus 3 square is 9, plus 2ab, that means 2 into 2k into 3, that is 12k. So it can be understood easily that 4k square plus 9 plus 12k is nothing but 2k plus 3 whole square. Now I'll write this left hand side part also. You observe here what happened. What happened? This statement is nothing but p of k plus 1. Try to understand what I am saying now. This is important. You assumed that p of k is true. You assumed that this statement is true. After adding a term on both sides, whatever you will get, that is also true. This is true. I did little bit of simplification in right hand side part and I got this. This is also true. This is nothing but p of k plus 1. So what I can say? I can say that p of k plus 1 is true. So what happened? We proved two things. First one, we proved p of 1 is true. Second one, by assuming p of k is true, we proved that p of k plus 1 is true. So what I can say? Therefore, by principle of mathematical induction, p of n is true. Hence, we proved the given statement by using principle of mathematical induction. Now we will move to next problem. You see this statement, prove that n into n plus 1 into n plus 5 is a multiple of 3. We need to prove this statement by using principle of mathematical induction. You can observe here, it is not like an equation. It is just a statement, mathematical statement. Here n is a natural number. We need to prove this statement by using principle of mathematical induction. To prove any statement by using principle of mathematical induction, we need to prove two things. First one, p of 1 is true. Second one, by assuming p of k is true, you need to prove p of k plus 1 is true. First, I'll consider given statement as p of n. You observe here, I considered given statement as p of n. Now, I need to prove two things. First one, p of 1 is true. How we prove p of 1 is true? First, in place of n, I'll write 1 in the given statement. Let's see what happens. You observe here, in the given statement, in place of n, I written 1. 1 into 1 plus 1 is 2 into 1 plus 5 is 6. And I written rest of all as usual is a multiple of 3. You observe here 1 into 2 is 2, 2 into 6 is 12. 12 is a multiple of 3. Why we got this? Because in place of n I written 1, that's why I got this statement. 12 is a multiple of 3. Is it correct? Is 12 is a multiple of 3? Of course, 12 can be written as 3 into 4. Clearly, 12 is a multiple of 3. This statement is true. We know that this statement is true. That means this statement is true for n equal to 1. So what I can write from this? I can write that p of 1 is true. So we proved first part of this question. What is the second part? Second part, you assume p of k is true. and you prove that P of k plus 1 is true. You observe here, I assumed P of k is true and I written what is P of k. How you will get P of k? In the statement P of n, wherever n is there you write k, then you will get P of k. See here, k into k plus 1 into k plus 5 is a multiple of 3. This is the thing we got. This problem is different compared to all other problems. Till now, in all other problems, we added a term on both sides to prove the things further. But this problem is not like that. You see here, what they given? K into k plus 1 into k plus 5 is a multiple of 3. So, what I can write here? I can write k into k plus 1 into k plus 5 is 3 into some integer, because they are saying it is a multiple of 3. So, I can write it as 3 into some integer p. What is p here? P is an integer. So I can write k into k plus 1 into k plus 5 is 3p. Okay. Now what is our main intention? We are trying to prove p of k plus 1 is true. You consider this. You observe here. This is p of k plus 1. Now I need to prove that this is multiple of 3. Okay. So this is a little tricky one. This is little tricky one, not very easy. If you know the trick, you feel that this is very easy. First, you understand what we are trying to prove. We are trying to prove that this is multiple of 3. I'll start simplifying this. At the end, I'll get 3 into some information here. I am trying to prove that this is multiple of 3. In the process of proving it is a multiple of 3, I am going to use this statement. As you assumed p of k is true, I am going to use this statement. Okay. You see the tricky part of this solution. K plus 1 into k plus 2 into, these things I written as usual. K plus 6, I'll write k plus 5 plus 1. This k plus 6, I'll write k plus 5 plus 1. Why I written like this? Because my intention is I want to use this step. In this step, k plus 5 is there. So that's why k plus 6 I written like this. That equal to k plus 1 into. Now I need to multiply these two terms. You consider like this: a plus b into c plus d. A plus b into c plus d. You multiply, what you will get? K into k plus 5 plus k into 1. With k I multiplied these two terms, plus with 2 you multiply these two terms. 2 into k plus 5 plus 2 into 1 is 2. Okay. That equal to k plus 1 into k plus 1 into k into k plus 5 plus all these things I'll simplify a little bit. 2 into k plus 5, that is 2k plus 10 plus 2. Okay. Now that is k plus 1 into k plus 5 plus, you see here, k plus 2k, that is 3k plus 10 plus 2 is 12. K plus 1 into this term plus k plus 1 into this term. So when I multiply k plus 1 into this term, I will get like this: k into k plus 1 into k plus 5. Okay. Plus, you observe in this 3k plus 12, I can take 3 common. Take 3 common. Then what you will get here? 3 in, if you take 3 common, 3 into k plus 4, when you multiply with k plus 1 to k plus 1. So you observe here, k into k plus 1 into k plus 5. To get this, I did this type of simplification. K into k plus 1 into k plus 5 is what? This is 3p plus 3 into k plus 4 into k plus 1. You can see this step. In this term 3 is there. In this term also 3 is there. So you take 3 common. What you will get? P plus k plus 4 into k plus 1. So what happened finally? K plus 1 into k plus 2 into k plus 6. We got it as a multiple of 3. Therefore, k plus 1 into k plus 2 into k plus 6 is a multiple of 3. What is this statement? This is p of k plus 1. So, what we proved? I proved that this is p of k plus 1. That means we proved that p of k plus 1 is true. So what happened? First I proved P of 1 is true. Next, second part, by assuming P of k is true, I proved P of k plus 1 is true. So by principle of mathematical induction, I can say that P of n is true. Hence, we proved given statement by using principle of mathematical induction. Let's move to the next question. You see this 20th question. We need to prove this statement by using principle of mathematical induction. First, which statement we are trying to prove, you take that statement as P of n. I considered given statement as P of n. Now, to prove this by principle of mathematical induction, we need to prove two things. First, we prove P of 1 is true. Second, by assuming P of k is true, we need to prove P of k plus 1 is true. First, we will prove the first part of this question, P of 1 is true. You observe in the given statement, in place of n, I written 1. 2 into 1 is 2 only. 2 minus 1, that is 10 power 2 minus 1. That is 10 power 1. 10 power 1 is 10 only. 10 plus 1, 11. 11 is divisible by 11. Here, is 11 is divisible by 11? Is it true? Is 11 is divisible by 11? Yes, of course. We know that 11 is divisible by 11. This statement is true. That means the given statement is true for n equal to 1. So what I can write? I can write that P of 1 is true. So first part of this question is completed. Second part. In second part, we assume P of k is true. By using that information, we will prove P of k plus 1 is true. Now, I'll assume P of k is true and I'll write P of k. You see here, I written P of k. How you will get P of k? In the statement P of n, wherever n is there you write k. Okay. Here we need to discuss few things. Suppose you take 4. 4 is divisible by 2. Is 4 is a multiple of 2? Of course. Suppose you take 10. If 10 is a multiple of 2, then 10 definitely divisible by 2. Correct or not? You take 25. 25 is a multiple of 5. It means that 25 definitely divisible by 5. So here 10 power 2k minus 1 plus 1 is divisible by 11. It means that if this expression is divisible by 11, it means that this expression is multiple of 11. So what I can write here, 10 power 2k minus 1 plus 1 is 11 into p. What is p here? Where p is some integer. You observe here, from this 10 power 2k minus 1 can be written as 11p minus 1. You just take this plus 1 to right hand side. Okay. Now, as I assumed P of k is true, I got this information. This is true. Now, our intention is, I am trying to prove that P of k plus 1 is true. This is P of k na. In this, in place of k, you write k plus 1. You see here, in this, in place of k, I written k plus 1. Let's see what happens. 10 power, multiply with 2, what you will get? 2k plus 2 minus 1 plus 1. Now, I am trying to prove that this is divisible by 11. See, it is a simple thing. First, I written 2k minus 1 plus 2 plus 1. Okay. We know the formula of a power m plus n. A power m plus n is a power m into a power n. See, this is like m plus n. A power m plus n can be written as a power m into a power n. So, this you can write like this. Why I written like this? Because I want to use this information. You see here, I know that 10 power 2k minus 1 is 11p minus 1. So what I do, in place of 10 power 2k minus 1, I'll write 11p minus 1 into 10 square plus 1. Now multiply 11p into 10 square is 100 minus 1 into 10 square, that is 100 plus 1. That equal to, do not multiply 11 into 100 because I am trying to prove that this expression is multiple of 11. If this expression is multiple of 11, I can say that this expression is divisible by 11. 100 minus 100 plus 1 is minus 99. So you see here, you can take 11 common. If you take 11 common, what you will get? 100p minus 9. I written this by considering p of k plus 1. So I got that this is a multiple of 11. this expression is multiple of 11. If this expression is multiple of 11, this expression definitely divisible by 11. What is this? This is p of k plus 1. So what happened? Therefore, we proved that p of k plus 1 is true. What happened? We proved two things. First, I proved p of 1 is true. Next, by assuming p of k is true, we proved p of k plus 1 is true. So, by principle of mathematical induction, p of n is true. That means we proved given statement by using principle of mathematical induction. I hope you understand this class.